Hi, I'm Gaurav and I'm presenting some preliminary work on adaptive quality diversity for learning to coordinate in multi-agent systems. This work was done in collaboration with Charles Koll and Tumer at the Collaborative Robotics and Intelligent Systems Institute at Oregon State University. We are looking at problems where multiple heterogeneous agents must learn to coordinate on diverse tasks. Agents in such systems should be able to learn a diverse set of behaviors. Recently, quality diversity methods have provided us with tools to shift the focus of evolutionary approaches to diversity search instead of just optimization. So quality diversity methods can be typically described as iterative processes that have two primary operations. The first is organization of behaviors into clusters in a behavior space based on some characterization of them, and then local competition within those clusters for optimality. This generally generates a repertoire of solutions that are both optimal and diverse. Adapting this diversity search method to our multi-agent problem is hard due to the diversity in both tasks and capabilities of the agents. The method I'm presenting today, multi-agent quality diversity, or MAQD for short, addresses this by imposing a hierarchical structure to learning. A top-level evolutionary method optimizes for fitness and guides the direction of the quality diversity method at the bottom level of the hierarchy. This ensures that the quality diversity method only explores regions of the behavior space that are currently relevant to the task of the environment as dictated by the fitness in that task. So let's walk through the figure in the middle. Subfigure A shows several initial behavior policy niches. In subfigure B, teams of agents are assigned these behaviors. Agents are simply neural networks that operate in the environment using these assigned behavior policies as actions. Teams are evaluated and assigned fitness using CCEA in subfigure C. Now the behavior policies corresponding to the agents that are discarded in this evolutionary step are removed, and this is shown in subfigure D. With the surviving behavior policies, we mutate and evolve them and then organize them back in the behavior space. So really, subfigures A through C are the top of the hierarchy, and subfigures D and E are the quality diversity parts, which are the bottom of the hierarchy. We test this approach in a multi-agent coverage problem where agents must jointly observe a set of diverse goals. MAQD incrementally refines the behavior niches as described previously. This incremental update provides us the ability to adapt to goals. So that the agents are able to adapt as goals in the environment change. The ability to adopt is very crucial, as is evident from the MAQD pre-trained curve. In this setup, we start with a predefined set of behavior niches. So the performance really depends on the quality of chosen niches and the available domain knowledge to actually design those niches. As a baseline, we compare the performance to map elites, where agents act in an environment using the entire behavior repertoire. Without even accounting for the cost of learning the entire repertoire, agents still fail to do well because of the large action space that is required to operate using the entire behavior space. So the final takeaway is that a hierarchical combination of optimality search and diversity search allows us to guide the quality diversity methods to allow to only find diversity in relevant parts of the behavior space. If you have any questions, feel free to email them to me at dixitg@oregonstate.edu. Thanks.